Today we will use perfect square factorization to simplify radicals. Simplifying radicals is like simplifying fractions. Whenever you see a radical, you ask yourself, can I simplify it? Here is the vocab. A radical is the formal name for a square root symbol. A square root symbol is called a radical. A radical can be a cube root. That means there's a little 3 on the shelf. If there's nothing on the shelf, there's an imaginary 2 there. You can also have a 4th root or a 5th root and so on. Pause the video and write down the vocabulary. The steps are listed here. 1, 2, 3, 4. We are going to factor the radical into a product of a perfect square, that is, the biggest perfect square that goes into the number inside the radical and the other factor, so that the two of them multiply to get that number. For example, we started with the square root of 20. What is the biggest perfect square that goes into 20? That would be 4. So I'm going to write that as the square root of 4 times the square root of 5. Do I know what the square root of 4 is? I do. It is 2. Do I know what the square root of 5 is? I do not. It will stay inside the radical. That is a simplified radical. This is our perfect square. This is the number that is not a perfect square. All right, so we just did the square root of 20. Again, we rewrite that as the square root of 4 times the square root of 5. Square root of 4 is 2. Square root of 5 is the square root of 5. There's another way to do this, and that is to create a factor tree. 20 can be written as 4 times 5. 4 can be written as 2 times 2. Bring down the 5. I have factored 20 into its prime factors. I call this jailbreak. We are trying to break somebody out of jail, as many somebodies as possible. Because there's an imaginary 2 sitting on the shelf, it takes 2 to break 1 out of jail. So we circle the pair. 1 dies, 1 escapes. The 5 does not have a partner, so the 5 has to stay in jail. That is another way to simplify a radical. Square root of 48. We ask ourselves, what is the biggest perfect square that goes into 48? The answer is 16. So I can rewrite square root of 48 as square root of 16 times square root of 3. Do I know what the square root of 16 is? I do. It is 4. Do I know what the square root of 3 is? I do not. Do I care? I do not. It will stay as the square root of 3. If we were to do the jailbreak method, I could rewrite this as 12 times 4. 12 is 6 times 2. 4 is 2 times 2. 6 is 3 times 2. I bring everything else down. Again, it takes a pair to break 1 out of jail, so I circle a pair. 1 dies, 1 escapes. Circle a pair. 1 dies, 1 escapes. All of this is going to be multiplied. The 3 does not have a partner. He has to stay in the jail. 2 times 2 is 4, so I get 4 times the square root of 3. Two different ways to simplify radicals. Sometimes there's a number already on the outside. In this case, we have a 3 that's going to multiply with anybody who does break out of the jail. So I'm going to set the 3 off to the side here and ask myself, what is the biggest perfect square that goes into 75? The biggest perfect square that goes into 75 is 25. So I get 3 times the square root of 25 times the square root of 3, because 25 times 3 is 75. 3/4 is 75 cents. All right. Do I know what the square root of 25 is? It is 5. And I have a 3 on the outside waiting. Do I know what the square root of 3 is? I do not. The 3 will stay on the inside. 3 times 5 is 15. And I get 15 times the square root of 3. Here's your U-try. It is similar to the one we just did in that it has a 3 on the outside waiting to multiply with whoever comes out of the jail. All right. I can multiply numbers that are inside together. I cannot multiply a number outside with a number inside. That's why we write answers as 3 times the square root of 2, because I can't simplify that any further. But I can simplify this by writing it as the square root of, what is 3 times 18? 54. The first thing I want to do is get everything in one radical. Now I ask myself, what's the biggest perfect square that goes into 54? Remember when we memorized perfect squares? This is one of the reasons. The biggest perfect square that goes into 54 is 9. So I'm going to rewrite that as the square root of 9 times the square root of 6. Do I know what the square root of 9 is? I do. It is 3. Do I know what the square root of 6 is? I do not. Do I care? I do not. I can do the jailbreak method. Let's see, 27 times 2, 9 times 3 times 2, 3 times 3 times 3 times 2. There's a pair, circle 1, 1 dies. These two have to stay in the jail. 1, 3 escaped. 3 times 2 is 6. I got the same answer. All right, the one at the bottom here, again, I want to get it all into one radical. I can multiply the numbers together. 3 times 18 is 54. I got x squared and y to the 5th. Okay, so how many pieces am I going to break this up into? 5 pieces. 54 is going to be 2 pieces. X squared is a perfect square, so that's going to be 1 piece. Y to the 5th is not a perfect square, so that's 2 more pieces. So I'm going to rewrite this as the square root of 9 times the square root of 6 times the square root of x squared times the square root of y to the 4th times the square root of y. Remember, the question for each item is, what's the biggest perfect square that goes into 54? That was 9. X squared is a perfect square. X times x is x squared. X squared times x squared is x to the 4th. X to the 3rd times x to the 3rd is x to the 6th. Any variable to an even exponent is a perfect square. Y to the 5th is not a perfect square, but I can break it up into y to the 4th. That's the biggest perfect square that goes into y to the 5th, and y. Now I'm going to take the square root of the things I can. The square root of 9 is 3. The square root of x squared is x. The square root of y to the 4th is y squared. The square root of 6 and the square root of y have to stay inside the radical. Simplifying radicals. Here's your u-try. Again, you want to get it all into one radical first, and then start breaking it apart. One more thing we need to talk about. When we are adding radicals, radicals act just like variables. For example, can you add 2x and x together? You can. You will get 3x. Can you add 2x and y together? You cannot. It stays 2x plus y. So radicals can be added only if they have the exact same thing inside the radical. So what I have to do is simplify each one of these first. Square root of 27, I'm going to rewrite as square root of 9 times square root of 3. 12, I'm going to rewrite as square root of 4 times square root of 3. Do I know what the square root of 9 is? It is 3. And I get 3 times the square root of 3 as the square root of 27. Do I know what the square root of 4 is? I do. It is 2. And I have 2 times the square root of 3 as the square root of 12. Now, can I add these two terms together? I can, because they have the exact same thing inside the radical. So 3 root 3 plus 2 root 3 is 5 root 3. Same thing down here in the second one. I'm going to rewrite square root of 50 as square root of 25 times the square root of 2. Square root of 25 is 5. Square root of 2 stays as is. What's the biggest perfect square that goes into 18? Biggest perfect square is 9, so I get the square root of 9 times square root of 2. Square root of 9 is 3, so I get 3 times the square root of 2 plus square root of 3. Do I have any like terms? I do. Positive 3 root 2, positive 5 root 2. Those are like terms. What do they add up to? 5 root 2 plus 3 root 2 equals 8 root 2. The plus square root of 3 is not a like term. He has to be by himself. Okay. Over here I have a 2 that's sitting out waiting. Square root of 20 and square root of x. What's the biggest perfect square that goes into the square root of 20? Square root of 4, whoops, times square root of 5 times square root of x. Plus, what's the biggest perfect square that goes into 45? 9. So I get square root of 9 times square root of 5 times square root of x. Do I know what the square root of 4 is? It is 2. So I have 2 times 2 times the square root of 5x. Over here I have 3 times the square root of 5x. So that's 4 times the square root of 5x plus 3 times the square root of 5x. Can I add those together? I can. They have the exact same thing inside the variable. 4 plus 3 is 7, so they add up to 7 times the square root of 5x. Okay, that's it. We'll go over everything together in class. Here is your u-try number 3. Square root of 6 plus square root of 24.